For this particular problem, we can solve by any method we choose. I notice that neither of these are in standard form or have a variable by themselves. However, this bottom equation here would not be very hard to solve for x. So let's go ahead and do that, and then we'll replace it in the first equation and see what happens. So first thing I'd like to do is get rid of these fractions. So if I multiply everything by 2, I'll have 2x plus 3y equals 3. Now, let's go ahead and subtract 3y from both sides. That gives us 2x equals, we subtract 3y here, so it's not there on that side anymore, but we have a 3, and then we subtract 3y here also. Now, if we divide both sides by 2, we find out that x equals 3 minus 3y over 2. We can now take this value and replace the x in the other equation with it, and that'll give us an equation we can solve. So let's do that. We're still going to have everything we have over here. We'll have the 4 plus 3 times y minus 3 equals, we have our negative 2 times, we're going to replace the x with this and have 3 minus 3y over 2 plus that 1. Now if we simplify, we'll see what happens. Distributing our 3 here, we're going to keep our 4 there and have 3y minus 9. And then here if we distribute our negative 2, the 2's will cancel and this will be negative. We'll change the signs of these to get a negative 3 plus 3y. And then negative 2 times 1 is negative 2. Combining our like terms here, we get 3y minus 5, because negative 9 and 4 is negative 5. Combining our like terms here, negative 3 and negative 2, makes it so we have a negative 5, and we still remain with our 3y. Notice something right here. We have the same expression on both sides. If we were to subtract 3y from both sides, we'd end up with negative 5 equals negative 5. And then if we added 5 to both sides, we end up with 0 equals 0. All the letters are gone, and this isn't a true statement. What that tells you is that these two lines here were actually the same line, just written in different forms, so they're kind of disguised. So that means that every point that works in one equation will work in the other. So we would say that the set of points where these two cross in set builder notation is the set of all ordered pairs x, y, such that, and then you put the equation of the line, so we restrict these ordered pairs to some rule. I'm going to use this form of the line right here because that's simpler than these two. So that would be 2x plus 3y equals 3. You can also use the slope-intercept form of the line in this place right here of your set builder notation. What that would look like if we wrote this so that this was in slope-intercept form would be the set of all ordered pairs x, y such that y equals negative 2/3 x plus 1. Either of these would be fine for your answer.